Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Amazon Relational Database Service, or RDS, is designed to take the heavy lifting out of running relational databases. Traditionally, organizations had to spend significant time installing, configuring, patching, and monitoring database software themselves. RDS changes that by providing a managed environment where AWS automates many of these operational tasks. This managed model means administrators can focus less on maintenance and more on using the database to drive business outcomes. Automated backups, high availability options, and monitoring tools are built in, providing resilience without requiring deep operational expertise. For learners, it's helpful to think of RDS as a middle ground. You still choose the database engine and design your schema, but you delegate much of the undifferentiated work like patching and recovery to AWS. This balance makes RDS one of the most widely adopted services in the cloud ecosystem. One of the strengths of RDS lies in the breadth of engines it supports. Developers can select from popular open-source systems like MySQL, PostgreSQL, and MariaDB, or choose commercial options like Oracle and Microsoft SQL Server. This flexibility means teams don't have to abandon their existing expertise when moving to the cloud. They can continue to use familiar tools while benefiting from managed operations. For example, a financial application that relies on SQL Server's enterprise features can migrate to RDS without losing those capabilities. Meanwhile, startups building modern web applications might prefer Postgres for its extensibility and standards compliance. The fact that RDS supports multiple engines under one umbrella reflects AWS's philosophy of meeting customers where they are, rather than forcing a one-size-fits-all approach. Underlying these engines are the compute and storage resources that power them. RDS offers a range of instance classes, similar to EC2, that define the amount of CPU, memory, and network throughput available to the database. Choosing the right instance class is a matter of balancing performance needs with cost efficiency. Storage types add another layer of flexibility. General-purpose SSD, GP2 or GP3, balances performance and price, while provisioned IOPS IO1 or IO2 delivers consistent, high-throughput performance for demanding workloads. These storage types allow organizations to match infrastructure to workload requirements, whether they're running small development databases or mission-critical production systems. Just as a driver chooses between a compact car or a heavy-duty truck depending on the job, database architects choose instance and storage configurations to align with expected traffic and performance demands. High availability is a central concern for relational databases, and RDS addresses this with multi-AZ deployments. In this setup, AWS maintains a synchronous standby replica in another availability zone within the same region. Because replication is synchronous, transactions are committed on both the primary and standby simultaneously, ensuring data consistency even during failover. If the primary instance becomes unavailable, whether due to hardware failure or maintenance, RDS automatically promotes the standby to take its place, minimizing downtime. This level of resilience would be challenging and resource-intensive to configure manually, yet with RDS it becomes an option you can enable with a few clicks. For businesses where downtime directly translates into lost revenue or trust, Multi-AZ provides confidence that the database will continue serving requests reliably. Scaling read-heavy workloads requires a different approach than availability, and this is where read replicas come in. Unlike Multi-AZ, which is synchronous, read replicas use asynchronous replication, meaning the replica can lag slightly behind the primary but is still highly useful for distributing read traffic. Applications can be configured to direct read queries to replicas, easing pressure on the primary instance. The benefit depends on the engine. MySQL, Postgres, and MariaDB support read replicas on RDS, while Oracle and SQL Server rely on their own mechanisms. Imagine a reporting dashboard pulling from a replica while the main application continues to update the primary. This separation ensures both sets of users get the performance they need without interfering with one another. Read replicas thus provide both scalability and a degree of resilience, though they are not substitutes for backups or synchronous standby. Speaking of backups, RDS simplifies one of the most critical aspects of database management. Automated backups capture daily snapshots of your database and transaction logs, enabling point-in-time recovery. This means you can restore your database to any second within your retention window, typically up to 35 days. In addition to automated backups, manual snapshots can be taken at any time and retained indefinitely, offering a way to preserve a database state before major changes. Consider a development team about to apply a risky schema migration. Taking a manual snapshot provides a safety net if things go wrong. These features ensure that recovery from data loss or corruption is straightforward, reducing the anxiety that often surrounds database operations. By turning backup management into a background process, RDS enables teams to adopt best practices effortlessly. Beyond the basics of compute, storage, and backups, RDS allows fine-grained configuration through parameter groups and option groups. Parameter groups let administrators define settings that control database behavior, such as memory allocation or logging levels. These can be applied consistently across instances to standardize configurations. Option groups, on the other hand, enable engine-specific features such as Oracle's transparent data encryption or SQL Server's advanced auditing. This separation between generic parameters and engine-specific options keeps management clear and flexible. For example, a company running both MySQL and Oracle on RDS can apply uniform monitoring parameters across both, while still enabling specialized features unique to each engine. These tools highlight how RDS balances automation with customization, giving organizations control without overwhelming them with manual configuration. Networking considerations are another important part of RDS deployment. Security groups act like virtual firewalls, controlling which IP addresses or other AWS resources can connect to your database. Subnet groups determine where in your VPC the database resides, ensuring placement across multiple availability zones for resilience. Together, these settings dictate who can talk to the database and from where. For instance, a production database might be locked down so only application servers in a private subnet can reach it, while blocking all direct internet access. By contrast, a test database might be temporarily exposed to a developer's IP address for troubleshooting. These networking controls are essential for enforcing least privilege access and preventing accidental exposure to the broader internet, a common cause of data breaches. RDS also provides strong encryption capabilities to protect sensitive data. Encryption at rest is achieved through AWS Key Management Service, KMS, ensuring that data stored on disk is unreadable without the appropriate keys. This includes not just the database files, but also backups and snapshots. Encryption in transit is equally critical, and RDS supports Transport Layer Security, TLS, to secure data moving between the application and database. For applications handling personally identifiable information or financial data, these features are often not just best practices but compliance requirements. By offering encryption as a managed feature, RDS lowers the barrier for organizations to meet security standards. Learners should note that enabling encryption at creation time is straightforward, but retrofitting it onto existing databases requires additional planning. Authentication is another area where RDS integrates with broader AWS identity services. For MySQL and Postgres, IAM database authentication allows users to connect to the database using temporary IAM tokens instead of static passwords. This removes the need to manage long-lived credentials, reducing the risk of leaks or mismanagement. Developers can assume IAM roles to obtain a token, which expires after a short period, ensuring access is tightly controlled. This approach aligns with modern security practices of minimizing reliance on static secrets. While not supported for all engines, IAM authentication provides a compelling option for those looking to centralize identity management across AWS resources. It highlights how databases, often siloed in traditional architectures, can now integrate seamlessly into an organization's security fabric. Managed services require ongoing maintenance, and RDS builds this into its operating model. Administrators can define maintenance windows, periods when updates and patches will be applied to the database. While AWS automates patching, you retain control over timing to avoid disruptions during critical business hours. Minor version upgrades can also be scheduled or deferred, balancing the need for security and stability against operational considerations. This level of control helps teams align database maintenance with business rhythms, such as scheduling upgrades overnight or on weekends. For learners, it's important to recognize that managed doesn't mean maintenance-free. It means maintenance is predictable, automated, and less error-prone. By planning around these windows, organizations can keep their databases secure and up to date without surprise interruptions. Visibility into performance is essential for tuning and troubleshooting, and RDS includes tools to support this need. Performance Insights provides a dashboard that highlights database load, query activity, and bottlenecks, helping administrators quickly identify problematic queries or inefficient code. Enhanced monitoring goes further by exposing detailed operating system metrics, such as CPU usage and disk I/O, with 1-second granularity. Together, these tools transform the database from a black box into a transparent system where issues can be diagnosed and addressed. For example, if an application suddenly slows, administrators can use Performance Insights to see if a specific query is monopolizing resources. These capabilities reduce the guesswork and provide evidence-based guidance for optimization, making database management more proactive than reactive. Another aspect to consider is licensing, especially when working with commercial engines like Oracle and SQL Server. RDS offers two models: Bring Your Own License, BYOL, where you apply licenses you already own, and License Included, where AWS provides the license as part of the service. BYOL can be cost-effective for enterprises with existing agreements, while License Included simplifies procurement and billing. Understanding these options is important not only for budgeting, but also for compliance. Licensing can be a complex topic in traditional IT, but RDS streamlines it by offering clear, managed pathways. This ensures organizations can stay compliant while still benefiting from the operational simplicity of a managed service. Finally, the cost model of RDS is built around instance hours, storage, and I/O. You pay for the compute instance class you select, the size and type of storage provisioned, and the I/O operations performed. Backup retention also influences costs, as longer retention periods require more storage. This model encourages thoughtful resource management, choosing the right instance size, using appropriate storage classes, and configuring backups wisely. For example, a development environment might use smaller instances with minimal backup retention, while production requires larger instances and longer retention windows. By aligning configurations with workload needs, organizations can optimize costs without sacrificing reliability. In this way, cost management becomes part of good architectural practice, not just a financial afterthought. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Scaling a database is not a one-size-fits-all endeavor, and RDS supports both vertical and horizontal strategies. Vertical scaling, also known as scaling up, involves moving to a larger instance class with more CPU, memory, or storage performance. This is often the simplest path, but comes with natural limits. There is only so large an instance you can choose. Horizontal scaling, on the other hand, distributes workloads across multiple instances. In RDS, this is typically achieved through read replicas, which offload read traffic from the primary database. For example, an e-commerce application might scale vertically during initial growth, but but eventually adopt replicas when read-heavy traffic spikes during holiday sales. Choosing between these approaches depends on workload characteristics, cost, and growth trajectory, reminding us that scalability is as much a design philosophy as a technical feature. Managing connections at scale is another challenge, especially when applications create hundreds or thousands of database sessions. RDS Proxy addresses this problem by pooling and reusing established connections, reducing the overhead on the database engine. Without a proxy, spikes in user activity can overwhelm the primary instance with connection requests, even if query volume remains manageable. RDS Proxy sits between applications and the database, smoothing out these bursts while also improving security by integrating with IAM for authentication. For example, a mobile app that experiences sudden login surges benefits greatly from a proxy, ensuring stable performance during peak events. By reducing connection churn and handling failovers gracefully, RDS Proxy turns connection management from a fragile bottleneck into a reliable, optimized component of the architecture. Backup strategies in RDS go beyond simply enabling the default automated backups. Thoughtful planning requires considering retention windows, snapshot policies, and restore testing. Retention determines how long automated backups are available, while snapshots provide long-term, on-demand points for rollback. Equally important is verifying that restores actually work. Organizations often discover gaps only during emergencies, when a backup fails to restore properly. Regularly testing restores into isolated environments ensures confidence and validates recovery time objectives. For example, a bank might restore a backup weekly to confirm that all transaction data is intact and queries run as expected. In this way, backups shift from being a checkbox compliance item to a robust part of resilience strategy, proving their worth when systems are most vulnerable. For organizations operating across multiple regions, RDS offers cross-region read replicas as both a performance and disaster recovery tool. By maintaining replicas in geographically distant regions, businesses can serve global users with lower latency while also preparing for worst-case scenarios. Should a region experience a prolonged outage, a replica can be promoted to a standalone database, providing continuity of service. Consider a social media platform with users in North America and Europe. Placing replicas in each region reduces response times, while also ensuring resilience if one region fails. These capabilities demonstrate how RDS fits into global architectures, balancing availability, performance, and recovery. The decision to adopt cross-region replication should weigh cost against the criticality of data and the expectations of end users. Networking considerations remain central, as databases interact with both cloud and hybrid environments. Private endpoints allow RDS instances to be accessed securely within a VPC, preventing exposure to the public internet. Placement in private subnets ensures that only approved application servers or services can connect, reducing attack surfaces. Security groups further refine these controls, defining which ports and sources are permitted. For example, an HR applications database might only allow connections from specific application servers, blocking all external IP ranges. This layered approach ensures databases remain isolated from unnecessary traffic, reinforcing the principle of least privilege at the network level. While it can be tempting to relax these controls for convenience, the long-term consequences of exposure can be catastrophic, making careful network placement an essential design decision. Security hygiene in RDS extends beyond network isolation. Following least privilege principles ensures that users and applications only receive the minimum rights needed to perform their tasks. Rotating credentials regularly reduces the risk of compromise, while auditing ensures accountability for database access. Perhaps most importantly, RDS databases should not be configured with public internet access unless absolutely necessary. Many high-profile breaches trace back to misconfigured databases left open to the world. AWS provides guardrails such as IAM authentication, parameter groups, and monitoring to enforce strong security practices. Organizations that integrate these features into routine operations not only protect their data, but also build a culture of security awareness. In this way, hygiene becomes less about technical enforcement and more about a disciplined mindset of minimizing exposure at every layer. Migrating into RDS is a common task. An AWS Database Migration Service, DMS, offers a path with minimal downtime. DMS continuously replicates data from a source database, whether on-premises or in another cloud, to a target RDS instance. This replication includes ongoing changes, so the target remains up to date until the cutover. A retailer moving from an on-premises Oracle database to RDS Postgres, for example, could use DMS to synchronize data in real time, only switching production traffic once validation is complete. This incremental approach reduces risk, avoiding the big bang migrations that often disrupt business. By pairing DMS with RDS, organizations gain both a modern managed platform and a safe, tested method of transitioning existing workloads. Keeping databases patched and stable is part of an ongoing maintenance playbook. RDS simplifies this by allowing administrators to schedule patching within designated maintenance windows. Still, rolling changes require planning, particularly for applications with strict uptime requirements. Testing patches in non-production environments before applying them to production helps avoid surprises. Additionally, monitoring after upgrades ensures performance remains stable. Think of maintenance as routine medical checkups. They may seem mundane, but they prevent small issues from becoming crises. With RDS automating much of the process, teams can focus on strategic decisions, such as when to adopt new features rather than firefighting operational tasks. This structured approach turns maintenance from a reactive scramble into a predictable, low-risk routine. Observability is essential for long-term stability, and RDS offers multiple tools to support it. Beyond CloudWatch metrics, slow query logs highlight inefficiencies in how applications interact with the database. Regularly reviewing these logs helps teams identify poorly written queries or missing indexes. Setting alarms ensures administrators are alerted when thresholds for CPU, storage, or replication lag are exceeded. For example, an unexpected surge in replication lag could indicate either a design flaw or a sudden workload change. By incorporating these tools into daily operations, organizations shift from reactive troubleshooting to proactive optimization. Observability thus becomes less about firefighting and more about ensuring the system continues to evolve alongside application demands. Even with strong tools, common pitfalls can undermine RDS deployments. Storage limits, for instance, can cause unexpected outages if growth isn't monitored or autoscaling isn't enabled. Maximum connection limits, often overlooked, can throttle applications during traffic surges. Parameter drift, when settings gradually deviate from intended baselines, can lead to inconsistent performance or security gaps. Each of these pitfalls underscores the importance of vigilance and discipline. RDS provides features like auto-scaling storage and parameter groups to mitigate risks, but they must be actively used. Awareness of these failure points allows administrators to prevent small oversights from escalating into major outages, reinforcing the idea that managed services still require thoughtful stewardship. Controlling costs is a constant balancing act. Right-sizing ensures you are not paying for unused capacity, while features like storage autoscaling help prevent costly outages without manual intervention. For non-production environments, stopping instances when not in use can reduce expenses significantly, though not all engines support this feature. AWS pricing calculators can help forecast expenses by modeling instance hours, storage, and backup retention. For example, a development team might keep a staging database stopped overnight and on weekends, cutting costs without affecting productivity. By weaving cost controls into operational routines, teams align spending with value delivered, ensuring databases remain both efficient and sustainable. The decision between RDS and Aurora often arises as both provide managed relational databases. RDS offers broad engine support and familiarity, making it a natural fit for organizations wanting managed versions of existing systems. Aurora, in contrast, is AWS's cloud-native relational engine, designed for higher performance and resilience, with features like distributed storage across multiple availability zones. Aurora can deliver up to 5 times the throughput of standard MySQL or PostgreSQL, but it is limited to those engines. Choosing between the two depends on whether you prioritize compatibility with existing commercial engines or desire the benefits of a fully cloud-optimized platform. Both fit within the managed database ecosystem, but they serve slightly different needs. From an exam perspective, learners should focus on identifying which RDS features align with availability, scalability, and security requirements. Multi-AZ deployments ensure resilience for production workloads, while read replicas provide scalability for read-heavy use cases. IAM authentication, encryption options, and security groups highlight the service's strong security posture. Maintenance windows and monitoring tools emphasize operational predictability. By mapping features to use cases, exam questions become less about memorization and more about applying architectural reasoning. Understanding these building blocks equips you not only for exam success, but also for real-world design challenges, where trade-offs and priorities must be balanced. In conclusion, Amazon RDS delivers managed relational databases that combine automation, resilience, and security with the flexibility of multiple engines. By offloading undifferentiated tasks such as patching and backups, RDS allows organizations to focus on application value rather than infrastructure upkeep. Features like multi-AZ deployments, read replicas, IAM integration, and automated backups make it suitable for workloads ranging from startups to enterprises. Cost efficiency, observability, and scalability options further strengthen its role as a cornerstone of the AWS database portfolio. Ultimately, RDS is about predictability, providing consistent operations and trusted availability so that data remains reliable, secure, and aligned with the business outcomes it supports. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.